Hey ladies, so today we're working on section 8.2 where we're going to be dealing with transformations of logarithmic functions. So last section we looked at really just a basic generalized form of our log function. So that was y is equal to log c or base cx. And so in this section we're going to be applying transformations to this type of function, which will include reflections, stretches, and translations. And so what we can do is, in general, we can rewrite a logarithmic function with these parameters as y is equal to a base c times, or that'd be b times x minus h, and that's all adding with k. So one thing I just want to point out here is that we are using the same letters here, so we're using a, b, h, and k. So that should look familiar from last unit when we were looking at exponential functions. So, and that's actually exactly what's going to be happening, is that these same parameters, they're going to have those same effects on your logarithmic function. So moving in here, so let's look at a. So if you guys remember what happened with that a value from when we had an exponential function. If you guys remember that, that is a vertical stretch. And that's by a factor of that absolute value of a about the x-axis. And if we had a was negative or it's less than 0, then you would reflect it across that x-axis. Okay? Value b, or your parameter b, that will be a horizontal stretch by a factor of 1 over b, and that's the absolute value, about the y-axis, and then if it's less than 0 or it's negative, you will reflect it in the y-axis. Looking at h there, here we will horizontally translate k units. And just as a quick note, so this is the only parameter that can actually change the vertical asymptote and the domain. So remember, vertically translating, we're moving horizontally, so that's going to be changing your x values. Okay. So once again, this is the only parameter that can change the vertical asymptote and the domain. Okay. So here we're going to look at the next one is k. So this one, last but not least, if you guys could guess that, we will be vertically translating, or we will vertically translate k units. So that's going to be moving up or down. Okay. So if you guys compare this chart with what we did last unit, you're going to notice that this is the exact same thing. So it's kind of interesting to note how similar our exponential and our logarithmic forms are. Okay. So, but I guess just one quick note again. So if you guys remember last unit, you were supposed to apply the stretches first and then you're supposed to translate it. So that same rule is going to apply here. So if you guys say were to graph the original function, then you would apply those changes in order to do a and b first, then you would do the translation afterwards, okay? But if you want to, it just depends on, you know, how you want to graph this function. If you use your graphing calculator, if you graph it using the original function, or if you just do, say, the values just as they are. So it's up to you. We're going to take a look at some examples here just to kind of make sure that we still understand what was going on from last unit. Alright, and well, as we can see, my ink is still not properly working. It's just, you know, just wonderful. Okay, so in this first example here, we need to sketch the graph of y is equal to log base 4 x plus 4 minus 5. And here we need to state the domain, the range, the x-intercept, the y-intercept, and the equation of the asymptote. So for this first one, we are definitely going to be graphing this one by hand. This one I want you guys to have that practice about or trying to graph it by hand. And then these next two examples, if you feel that you know what, you've got graphing, it's totally fine. After this first example, go for it. Use your graphing use your graphing technology or your calculator. I just really want you to make sure that you've got this graphing by hand down. That way, in case we ever run into any problems, maybe your calculator goes out in maybe in the exam, which would be really unfortunate. But this way, you still know how to graph by hand if all else fails, or if you want to double check something. That way, you always have that basic knowledge about how to graph by hand. Okay. So to start here, there's a couple different ways. I think I already mentioned that about how we can graph, say, a transformed function. So first of all, we could start off with our original base function. So we had y is equal to the log 4 of x. This would be the original function, so with no transformations applied to it. Then from there, we just look at what parameters were applied, and then we can I guess move our graph accordingly. Or the other option is that we have just graph y is equal to log 4 of x plus 4 minus 5, just as it is, so we'd have to put those values in ourselves. So it's up to you guys how you guys want to graph it. Do it your own way, but either way we should end up with the exact same graph. Just know how you ladies work, okay? So how I want to do this is that I'm going to go with, we're going to make a table values for our original function, and then I'll make another table values where I won't have to do any calculations other than just applying those parameters, okay? So first off, we can talk about what parameters were applied here. So here we have, if you guys notice what's different about your base function or your original one compared to your transformed one. So here we have a plus 4 with our x, and we have a negative 5. So this here is our h and k. But if you guys remember, so h, when we're looking at our function, this is x minus h, so this has to be a negative. So h is equal to negative 4. So if you guys remember, h is a horizontally translate h units. So what's going to happen is when we have negative 4, it's going to shift 4 units to the left. Okay? And then our next parameter is, here we have this negative 5. So here we can say that k is equal to negative 5. If you guys remember what that means, so that k is vertically translate k units. So this one's going to be shifting 5 units, and it's going to be down because it's negative. Alright, so just to have that little understanding of what those parameters do, so if we went from our original function, so say if we graphed y is equal to base 4x, then what we would do is we would shift it 4 units to the left and then shift it 5 units down. Alright, so let's try it that way. So I'm just going to scroll down here a little bit so we can have a table of values. So to start, even if you guys want to, when we're dealing with log 4 of x, let's change that back into exponential form. So that'd be 4y is equal to x. So that might help you choose your table values. So here we have our x and y. It's going to be a bit of a short table. Alright, so from there we're going to choose, because our y is our exponent there, we're going to choose y values, okay? So here we can choose negative 2, negative 1, 0. I'm going to create a second one here. Then we have, say, 1 and 2. Create those nice values so that way they're a lot easier to work with. So when we have y is equal to negative 2, x is equal to 4 to the negative 2, which is equal to 1 over 16. When we have y is equal to negative 1, we have 4 to the negative 1, which is equal to 1 over 4. 4 to the power of 0 is equal to 1. And 4 to the power of 1 is equal to 4. And 4 squared is equal to 16. Okay? So this is our original function. Now from here we can actually even go in 2 more directions. So if you guys want to create a second table of values where we have, say, our changes, so you'd have x minus 4, we're shifting to left, and we could have y minus 5 using those parameters. Or what you could do is graph your original function. So maybe let's try that one out. So I'm just going to scroll on up here. Hopefully you ladies have that written down. So I'm just going to scroll back up and just keep your table functions handy so when you guys are graphing. So here, first of all, we will label our spacing. So we'll go by maybe every 2 tick marks, we'll go with 3. And with our y values, we'll go up I guess every line will be 1 unit. So Alright, so once we get that line spacing done, so let's graph our original function. I'll do this one in red. So so our first point there, we had -2, or y is equal to -2, and x is equal to 1 over 16. So we got something really, really close to that y-axis there. Then we had y is equal to -1, and x is equal to 1/4. So it's still probably going to look like it's in the exact same spot. Should be really close to that y-axis there. Then our next one, we had y is equal to 2, and x is equal to, oh sorry, we should have y is equal to 0, and x is equal to 1. Should be about a third of the way there. Or it should be about somewhere around there. And then we have y is equal to 1, and x is equal to 4. Maybe around somewhere around here. And then we have x is, now we're finally at y is equal to 2, and x is equal to 16 there. So it's probably going to be somewhere way out here. Okay, so from there we will graph it, or connect our little dots. Once again, I apologize for my shaky hand. These things are surprisingly very hard to work. Alright, so that's kind of a really rough, really, oh boy, version of y is equal to the log of 4x. And I'm going to quickly switch here some pens, and we are going to use our parameters. So this one I'll do in, let's do a purple. I like purple. Oh, or that didn't do purple. Alright, so according to our parameters here, we have that h is equal to -4, so that has a shift of 4 units to the left. And then we also have that k is equal to -5, where we shift 5 units down. So what we're going to do is we're going to take each individual point, and we're going to apply those parameters. So let's start here with 16 and 2. So we're going to shift it 4 units to the left to -12, and then we're going to shift that point 5 units down. So we're going to go from 2 to -3. Should be somewhere approximately right there. And then so for our next point, we had 4 and 1. So we're going to take that point and we're going to shift it 4 units to the left. Let's go from 4 to 0. Then we will shift down 5 units. So we will from 1 to -4. Then we'll take our next point there, which we had 1 and 0. So we're going to shift 4 units to the left. So it goes from 1 to -3. Then we're going to shift down 5 units, and then we go down to -5. Then our next point there, we have 1 and 0. So we'll shift 4 units to the left, which will give us to -3. Then we'll shift 5 units down, which will be down to -5 there. Okay, so then our next point, we have -1 and 1/4. So that's right over here. And that's we're going to shift 4 units to the left and 5 units down. So it's going to go from, so here we're at x is equal to 1/4. We're going to subtract 4, so that's at 3.75. So that's approximately maybe somewhere along this line here. And then we're going to go down 5 units, so we're going to go down to -6. So we'll probably be somewhere right along this, maybe somewhere around here. Okay? So then our last point, we have x is equal to 1 over 16 and y is equal to -2. So if you guys either don't want to do the math, you guys can throw this into your calculators. And you get that y should be, or x should be equal to -3.9375 when you put that into your calculators, which is probably somewhere, we're going to start getting a little bit closer to this line, but still not quite. And you have y is equal to, so we had y is equal to -2, we're going to shift that 5 units down. So now we're at -3.9 and -7, so we're probably going to be somewhere maybe right along here, okay? So from there we can connect our dots. I'm going to try and do my best. Oh boy, oh boy, oh boy. Alright. There we go. Okay, we made it through it. So that there is approximately, and we should label here, especially I have different colors, so it's a little bit nicer, but maybe let's label this. We have y is equal to the log of 4x. If we want to label our red, I'm just going to switch over to my red pen. and we'll switch over to the next video.